Welcome everybody to calculus. Here we're learning two of the most important rules, two of the three super important rules of differentiation, that is product rule and quotient rule. Product rule is when you have two functions multiplying themselves. Okay, you can always distribute them, but sometimes that's a huge pain, or sometimes you can't even do it, so you have to use the product rule. The product rule is when you have one function times another. Okay, this is it. This is the formula. A lot of people think it's just going to be, oh, it's just f prime times g prime. No, it's not. This is it right here. It's f prime g plus fg prime. This is the way I remember it. It's the first is first, and the second is second. Does it really matter what order we do this in? No, but there's a reason I do it this way, because I know what's coming up. So I always just do it in the same order. That way I don't mix it up when I do the quotient rule. So the first is first, the first derivative. Right, the first one gets the derivative, and the second one, the second derivative. I just rewrite it. First is first, second is second. This is how I remember it. Okay, so for number one, finding the derivative. I have two different functions here. Now, could you distribute this all the way through and find the derivative? Yeah, but that can be a lot of work when we, especially down the road. So I have two different functions going on here. Let's go pink and green. I have a green function, and then I have a pink function. Does everybody see how I have two different functions here? That's the hardest part for some people for product rule and quotient rule, is recognizing what the two functions are. So, what's the derivative of the first? What's the derivative of the first? 3 minus 4x. Very good. Did I change the second one at all? No, so I'm just going to leave it the same. So 5 plus 4x. Plus, I leave the first the same. And then what's the derivative of the second? It's just 4. Okay? If this is free response, you're done. Let's pretend this is multiple choice, because there's really a low chance this is free response. You would just need to simplify it from here, and this one isn't too bad to simplify. So you would get, let's do black for simplification here, so you're going to get 15 minus, there's actually 15 plus 12x minus 20x minus 16x squared. That's for the first one. Plus 4x minus 8x squared. Because I can't do math. I'm just making sure you're paying attention. Okay, so let's organize everything. Let's put my x squareds first. So I'm going to get negative 24x squared, because most of the answers in multiple choice are in ascending order, or descending order. How many x's do I have? Too many. 4? 4? Plus 15? That's it. It's probably the longest problem we'll do for product rule. The rest of them are a little bit quicker and more simple. Any questions on one? Just moving a little faster now. So I just want to get these done, those kind of done quickly, because I want you to do practice work on this one. So for the second one, what are my two functions? What's my green? What's my pink? X is the first, and then e to the x is the second. Let's do it. What's the derivative of the first? 1. And then this stays the same. Plus x. And what's the derivative of the second? What's the derivative of e to the x? Remember, it's so special. It's the derivative is itself. Okay. And again, you're actually done right there. But if it's multiple choice, they might want to simplify this. How can I simplify this? Yes, you can. There's a GCF of. So e to the x, which gives us 1 plus x. And there you go. You want to try the third one on your own? No. Try it on your own. How's my answer? Perfect? Mine? You know, you're disturbing everyone in here. No, he needs to learn. Too bad we couldn't, like, put this live on YouTube. Then we really could kick him out. Actually, put this live on YouTube. You all can just go home. If you have questions, just type them in the chat.
Yeah, later on. No, later on. No, live stream.
And the great thing about that is then everyone gets to see the questions in the live stream. It'd be perfect. And they can publish it as a video. Hey, let's do that next class. All right, so next class, no one show up. Well, but we do have a skills check. Probably might not work. Yeah, wait, you have a quiz too. You have a skills check and a quiz next class. Holy cow. Yeah, it's a short skills check to make sure that you know this, because I'd rather... This is what the problem is, usually, is this type of stuff. Number 4, want to try that one on your own? Okay. These are kind of obvious on what your different functions are, because it's kind of set up nicely. Go through this one on your own, see if my work matches yours. Alright, we good so far? This is where the GCF gets a little tricky. What's a good GCF here? Because we have a negative exponent and a positive one. What happens if I take out a GCF of the positive one? What happens to that negative one? So if I take out an x to the 1/2, I'm going to be left with 1/2. That becomes an x. Can we verify this, or am I just making this math up? Or no, this comes an x to the negative 1, right? So that's not good, right? Let's take out an x to the negative 1/2. So this becomes 1/2 times 4 minus x squared, which I can simplify. This becomes an x. And I can verify that, because x to the 1/2 times x is x to the 1/2. So I can verify that. And then this is negative 2x. So am I done simplifying? No, because this could be x to the negative 1/2. This is 2 minus 1/2 x squared minus 2x squared, which is x to the negative 1/2 of 2 minus 5/2 x squared. This is very algebra heavy, by the way. This is all algebra skills. But this might not even be an answer. I'm just letting. I'm doing this all because of multiple choice. Any one of these choices could be answers. I'm just keep simplifying until I'm like, oh, that looks like really neat and cool. So there's actually more simplification. What if I took out a 1/2? So what if I had 1/2 x to the negative 1/2, and then that 2 becomes a 4 minus 5x squared, which is really 4 minus 5x squared all over 2 square root of x. And that probably is what the answer is going to look like, just because they like to make these things into fractions. Anyone verify my math, or just all trusting me? Wow, that's a terrible thing to do. Okay, so again, when simplifying this, if you have exponential fractions or you just have negative exponents, take out the negative one. Right? It'll change the positive ones into nicer nicer value. So this extra 1/2 becomes just an x. And if you have fractions, take out the fractions as part of your GCF. It makes the fractions the whole numbers. Okay, you can verify this each step. If you're like, oh, I don't know if that step matches that step. Well, just distribute that 1/2 through and boom, it's the same thing. You just have to know how to go backwards. My expectations of your math skills are very high, so you need to be able to do this stuff. Questions on that one? Okay, number 5, find the equation of a tangent line. So we've done this. We're finding the equation of a tangent line. We essentially want y minus something equals slope. All right, I'm going to fill in these blanks. Equals slope x minus something. That's what I want. So I need to find the derivative. Well, what is f prime? Holy cow, that's not so easy to take the derivative of because it is... Very good, class. It is product rule. But what's nice about it is I'm plugging in a number. So do I need to simplify everything super nicely? Very good, class. No, I don't need to. So what's the derivative of the first? 3x squared, and then you leave the second. Plus the first, and then the derivative of the second is e to the x. Do I need to simplify this? No, because I just need to find f prime of 1. Let's plug in a 1. I'm going to get 3e plus e, which is 4e. So I found my slope. So my slope is 4e. My x value is 1. And what's my y value? So what is f of 1? E. Boom, that's the answer. Am I going too fast? You got a question over there? Okay. This is half of what's important for today. Here comes the other half. Quotient rule. This one's a little bit easier to kind of recognize because it's a division sign. It's a fraction. It's a little bit easier. So here's the formula for the quotient. How does I color code? I'm just making sure I color code it the same way. Oh, I won't color code it. Okay. This one's a little bit different. This is the first is first. Order matters now. And the second is second. So the first is first, second is second. You're subtracting, and this is all over the bottom one squared. So I call the first one is the top one, and the second one's the bottom one. So the first is first, second is second, second is squared, because it's a 2. So here we go. I have 2 functions on this first one, so let's go ahead and find the derivative. Let's do it up. So what's the first? What's the derivative of the first? Very good, class. 5. We're really engaged today. And the second is x squared plus 1 minus 5x minus 2, and the derivative of the second is 2x. All over everything that's not blue was really the calculus work. The rest of it was just plugging stuff in. And then from here on out, it's all algebra. I just need to simplify it, make it look nice and pretty. Typically, that bottom, you don't really do much to that bottom. Sometimes that bottom stuff cancels out. Sometimes we add to it, but I don't really mess with the bottom too much. Let's mess with the top, though. So you're going to get y prime equals, when we distribute that, I'm going to get 5x squared plus 5. And distribute that minus sign along with that 2x is going to give me minus 10x squared plus 4x. Is that correct? And this simplifies kind of nicely. Well, like not nicely, but like not terribly. So negative 5x squared plus 4x plus 5. And there's nothing else you can do, so that's it. Wasn't that so fun? I love calculus. I don't mind teaching those losers in pre-calculus because you know it's almost there, but it's not better than calculus. You know what's better than calculus 1? Calculus 2. I love Calc 2. Oh my god, that is the best. It's anti-differentiation is mainly Calc 2. You know what's even better than Calc 2? I love Calc 3 because Calc 3 adds another dimension. Oh, it's so awesome. There's no Calc 4. Well, I guess that could be differential equations, but there's really no Calc 4. Hey, why don't you try 7 on your own? 7's very basic, nothing complicated about it. Just go ahead and do it. Try 7. I'll do it along with you while color coding. Does the color coding help at all? Okay. Neelish, does the color coding help you at all? No. Okay. I want to serve Neelish, so I shouldn't color code anymore, right? G 2x squared minus 14x minus 4 all over bottom squared. Now you could take out a 2, but they probably wouldn't do that because it would just be sitting in front. I don't see them doing that. They don't factor unless anything cancels. So their answers always look like this. Unless it factors and cancels. If it factors and doesn't cancel, they don't usually do that. Hey, to the next one. What about two functions? Cosine and x cubed. This one's not going to take too much work to simplify it either. It'll be a little bit less painful, less writing. So here we go. So f prime of x equals the derivative of the top, which is negative sine of x. Please don't confuse that with that sine of x. Like that does not become x to the fourth. Sine of x is its own thing. That's why it's a different color. Minus cosine of x, and then times 3x squared. All over x to the, it should have been blue. X cubed squared, 6. Can I simplify the top of it all? Is there a GCF that will cancel out? There is a GCF that will cancel out. What is it? X squared. So I'm going to get negative sine of x minus 3. Oh, there should be an x in front of that, right? Yeah. So negative. I'm going to put the x in front of the sine of x. That's what the cool kids do, so I'm going to do that. So how does it simplify now? And don't forget those sine of x and cosine of x, those are all nested together. So you can't cancel out those x's with that x to the fourth. Questions, comments, concerns? Number 9's kind of nice. Why is it nice? What's the derivative of the top? That's really nice. So let's go ahead and find the derivative. So I'm going to get derivative of the top, which is 0. Also write the rest of it so you can see all the work. Minus 8. And then what's the derivative of the bottom? That first entire term there goes away. Negative 16x all over x squared plus 4 squared. And there's no more math to be done. That's nice. Love it. Alright, number 10. Let's find the equation of a tangent line to the graph again. This is what we're doing. Oh, okay. Radika. Mason. Yeah? Alright, hi, here we go. Watch out, everybody. I'm terrible at Frisbee. Yeah. Emily. Thank you, pass it down. Why do you have new IDs? What is this for? Oh. Hey, for those of you that just got an ID, I do need to take your old one. I need to take your old one. That's what it says. I need to take your old one. At your convenience, just leave it on my desk. Hey, I'm still recording. I'm still in the middle of the notes. Let's go ahead and finish this. Okay. So I can actually fill in most of this. This is my x. This is my y. I can fill in most of it already. So it's going to be -1. This will be a -1 right there. But to find that last blank, you have to find the derivative. So to find the derivative of f of x, which is kind of nice, we do not need to simplify. We just need to do the first step and plug in. So I have a green. What's the derivative of my green? -1. That's what I heard everybody say all at the same time. Fantastic. And then the bottom is pink. What's the derivative of the bottom? 1. I heard everyone say 1 overwhelmingly. So now I need to plug in a -1. So I'm going to get -1 times 4 minus 4 times 1. I don't need it. On the bottom, that's going to be 4 squared. Is that -1/2? -4 minus 4 is -8 over 16, -1/2. So, -1/2, make this a little bit prettier. It's y minus 1 equals -1/2 x plus 1. That's it. Product rule, quotient rule. We got a little bit more coming up too, so it's very simple though. Just derivatives of other tangent functions: tangent, cotangent, secant, cosecant. Ooh, I don't have the keyed notes. I have to memorize these. All right, here we go. See if we can memorize them. Tangent is secant squared of x. This better be right because it's not I have to erase the entire video. You're like, oh, he's joking. I'm not joking. I'm 95% confident in these. Cotangent, anytime there's a c in front, it's always negative, by the way. Because cosine, negative. Cotangent, negative. It's negative cosecant. Square root of x. You notice how these just come from there, here to here? And you can always derive these using product rule. Because you should know, or quotient rule, because you should already know what secant and cotangent are. They're sine over cosine. Take the derivative of that, you get this. Secant, I believe that is secant x tan x. How much confidence am I giving you that I'm saying this stuff? I'm confident enough to write it down. Okay. Now, I don't need to do all of these because, I don't need to do all of them. I'll just do, which one do you think we need to do? 13? But 13 doesn't even involve any of those trig functions. 14 is just that one minus that one. 11 is just e to the x minus secant squared of x. Let's just do 12. So what are my two functions? I have x, and I kind of just did all of them. That was sneaky of me. All right. So when I do this, y prime is equal to, what's the derivative of the first? So 1 times, you leave the second alone, secant of x plus the second, which is x. What's the derivative of secant? Is there a GCF? What is it? That's good enough for me. Too fast, too slow? I'm going to try to finish these notes in 2 minutes. I'm not going to do all these, because again, these are all kind of here for you. So here's a table. Finding this stuff. I feel like 17 is the most valuable one to do. So this gives you f prime, g, and g prime, gives you everything. So again, I don't really see a lot of value in doing 15, because that's just h prime is f prime plus g prime, and you just plug in the numbers at -1. For 16, that's just 3 f prime minus 5 g prime, and you just plug in a 4. So it's not that hard. So let's go ahead and do 17. I see a lot of value at 17. So for 17, this kind of already has product rule right in front of our faces. So let's go ahead and find p prime. So to find p prime, it's just a definition, isn't it? Sure. Okay, so let's plug in a -1. And we're going to get, what's f prime of -1? Look at our table at -1. What's f prime? 7. What's g at -1? 5. Plus, what's f at -1? 4. What's g prime at -1? You notice how we used everything in that table? It all got used. So this equals 43. Yeah, I guess so. Last part's super simple, so that's why I know I can rush through it. Super simple. Okay, real quick, notations for higher derivatives. So we can take derivatives of derivatives, of derivatives, of derivatives, of derivatives, of derivatives, and like forever. I can just keep taking derivatives. So the first derivative notation is f prime of x. Right? Or it is dy dx. Second derivative, that's f double prime of x. Or it is d squared y over dx squared. Third derivative would be f triple prime. I can't really tell that's triple prime. That's triple prime of x. Or it is d cubed y over dx cubed. Fourth derivative, that would be, different ways I've seen it. They'll just put a 4 in the parentheses like that. Or they'll do a Roman numeral, because technically it's all Roman numerals. So they'll do either one of those. Because the prime is actually Roman numeral 1, then Roman numeral 2, technically what it is. Or, you get the idea here, this would be d4y over dx. What's wrong, Neelish? I feel like I'm getting insulted somehow, but I don't care. Oh, don't be insulting them. I'm more offended that you're insulting the math than me. I'd rather get insulted. Don't be offending me. I love this stuff. I devoted an entire career to it. Alright, so what's the first derivative of this guy? Super simple. It's all power rule. Let's power rule through it. What's that? 20x cubed plus 9x squared minus 30x plus 20? So the second derivative is the derivative of the first derivative. 60x squared plus 18x minus 30 plus 0, don't care. The third derivative is the derivative of the second derivative. 120x plus 18, I don't care. The fourth derivative is 120. The fifth derivative is 0. Did you have fun? Me too. Well, no, because if you do trig functions over and over again, like they cycle through. And then number 19 just starts with the fourth derivative. So all you do is you find the fifth derivative. Again, really super fast here. I know we learn best when I talk really fast, so we'll just keep up that effort. Again, notation's a little different. I don't really care. And this is going to be 24x minus 10, final answer, and that is it. Done.